Ömer Hocam, misafirimiz geldi mi?
Hocam misafirimiz burada.
Ömer Hocam. Ömer Hocam sen bir normal afişi ver de Gank Hoca şey yapsın sonra ekran paylaşsın. Sen onu sonlandır. Alo.
Arkadaşlar profesyonel oldu.
Burada yanımda. Abi bir dur, introduction yapılacak sen.
Hello, could you hear me? Hello, could you hear me?
We can hear Professor. Session chairman will present you. Nabil.
Okay, I know this slide. Okay, welcome everyone. This is our 11th International Fiber and Polymer Conference. We are really happy and excited, so for that reason, please forgive us if we make any mistake. We do have our guest speaker, Professor Gang from UC Davis. I am going to tell about Professor Gang's actual resume. My friends, if you can reflect it. Yeah, Professor Sun is a professor in Department of Biological and Agricultural Engineering at University of California, Davis. His research activities include functional materials for biological protection to biocidal materials for PPEs, safety products, food safety products, and personal use sensors. Dr. Sun received Career Award from US National Science Foundation in 1997 and only medal in 2016, the highest science award, and Chapman Award in 2020 from AATCC, I believe, yeah. He's currently serving as the editor-in-chief for this journal as well, and he already published over 300 peer-reviewed journals. I'll be happy to introduce Professor Sun. The stage is yours, Professor.
Thank you very much for the introduction. Should I share my screen now?
Yes, please.
Okay. Good afternoon, everyone there, and thanks for the invitation and thanks for the opportunity to present my work in your conference. And also here, I have a co-author who was my postdoc and also PhD and made all the major contribution to this presentation. Hold on. So in this research, you're going to find out that we have some kind of research activities in the PPE, personal protective equipment related areas, including sensors, face masks, clothing materials. And also what you will hear is majorly you're going to see that we're using different fibers and materials, and also we're using traditional textile fibers and fabrics in our research. And also this research is focusing on the development of detoxifying and sensing and also functional materials. I did not read the title, but I think that everyone has the title. So I'm going to start here and the real topic and the presentation. So we started from the cotton fibers, and which is a common material that everyone is using, and also used for the clothing, used for the face masks, used for daily dressing. And also we're seeing that how do we change these fiber structures, and how do we make the cotton fibers and fabrics more productive in different functions, and also still wearable. And also we also will learn some of the very interesting and very simple approaches using chemical and some of this nanotechnology process. So we started with the fiber, with cotton. So everyone is familiar with this cotton, and here, and the cotton obviously is the cellulose with a lot of hydroxy groups. We could use the hydroxy group to add different functional groups. And also here is the common practice that in the industry. And if you're familiar with the textile finishing process, the Dow Chemical is selling a cotton is called salt-free and reactive for the reactive dyeing and cotton process. And in fact, they are going to, they added a kind of a positive charge or quaternize structures onto the cotton fibers, and they make the fiber surface carrying positive charge. So, and with the positive charge, what you're going to see is that the positive charge on this fiber will be strongly interactive with any kind of anionic species, including dyes and other chemicals. So that's the practice that used for so-called salt-free approach. But here also we're doing and with the same type of the concept. So we also treated our cotton fiber and also with another chemical, which is called the diethylene ethyl chloride. So this chemical has a potential that not only just build one of this amino, but also then will build our additional reactions built with the positive charge. And in fact, it form more positive charge. So we call it the polycationic chains. But these polycationic chains brings more positive charge and stronger electrostatic reactions with anionic species. That is the principle of this research. Very simple to demonstrate this type of interaction would be that when we use those DEAE treated cotton fabrics and to react with the dyes, and we don't need to use dye, we use salt in the dyeing, has a very strong interaction with the anionic dyes, any anionic dyes. So it will make the fabric strongly colored. And also, I just want to show you some kind of absorption and exhaustion pattern of these materials. Exactly, you see that without this treatment, you're going to see the exhaustions of the dye. With this type of treatment, you're going to see huge increase of the exhaustion. And actually, the absorption patterns of the dyes, we use a direct dye, not a reactive dye, but this dye in regular requires a lot of salt. Now we have very interesting in that it fits into the Langmuir adsorption. Well, that's just the beginning of the research. And also we see that these type of the polycationic structures would be also interactive with the other functional, functional agent. Simple functional agent is we call the photosensitizers, and those are anionic photosensitizers. The yellow one actually is very similar to the anthraquinone dyes, if you're familiar with those dye structures. And the pink one or the purple one, and I don't know what you see from your screen, would be a kind of a common biomedical use photosensitizer called the rose bingo. And now we are using the same type of electrostatic interactions, and we're able to add on to these fibers. And also now you see we can make it into a face mask material. And here's all the images of the morphology. And interesting part is it does, and the fabric and cotton fabric really absorb a huge amount of this rose bingo. Same thing as for this type of, we call the 2AQS. And you see the amount of this increase and become saturation at a certain level. When we use it, what happens is that the photosensitizers follow such a kind of mechanisms. When they absorb the light, obviously it got excited, and also excited status is mostly singlet, and the intersystem crossing will become a triplet. And actually triplet will go two possibilities to return to the ground state, type 1 or type 2. And to simplify this presentation, I don't want to go into a lot of photochemistry here. It goes by, and for this type of the chemical here, we use the rose bingo. And rose bingo here is represented as RB, is going primarily by the type 2. Type 2 interaction is that excited rose bingo structures will collide with the singlet, with our triplet oxygen, and producing singlet oxygen. Singlet oxygen is the very lethal and antibacterial agent of biocides. So here is a photo scheme, and the triplet oxygen, which is in the air we breathe in, interact with this surface under the light and generating singlet oxygen, which is very lethal to microorganisms. So now also we have the evidence, and the shaded area shows this the generation of the singlet oxygen, and here is underneath the gray area shows a kind of generation of a hydroxy radical, which are kind of a standard representative for generation going by this type 1 reaction, but this is the minor reaction. Well, also the interesting part is that when we have certain amount of this rose bingo onto it, another benefit is we still have a lot of positive charge on the surface that, and we consume some, but we still have it, which are more the residual positive charge, which are more interactive with the negative charged protein molecules. Here we use BSA, bovine serum albumin, as a representative. It really absorbs a lot. What's the purpose? And well, the purpose is that when we use certain amount of rose bingo to treat this type of the cationic cotton, it will provide very powerful, and here is you see 30 minutes, 60 minutes contact time on the light, provides very good kill. And it doesn't provide the function without the light. And also this is the E. coli, this is Listeria, which is a gram positive, gram negative. And this just shows evidence, but also you probably see here's a decrease, and I will explain why there's a decrease. And also we do have a solution, and that is our early stage of the work using this positive charged cellular structures. And here, remember that the difference is this polycationic species. And also you could, when you have such a structure, it's very interesting that you can, this type of the anionic charge due to this type of strong interactions can survive the laundry. This wash is not a kind of a speed up wash, it's a real wash. And this type of the strong wash, and it shows that there's no any reduction. And so this material obviously can survive in the dyes the colorant, the photosensitizer stays on very well. Another good antibacterial the biocidal function is it can kill virus. So we use a kind of bacterial features, bacterial virus, to demonstrate these functions, and obviously it shows very quick 6 log reduction, and in even 5 or 6 or 30 minutes time. So I need to cut it short and try to proceed with the other continuation in this work. And actually here is we continued the use of this polycation structures onto different fibers. Here is another example that we make this nylon and nanofiber membranes. And the use of this nylon nanofibers was to make the sensor. And actually we published a lot of this paper-based sensors for personal use in the field for detecting all different fumigants and the pesticides for the farm workers and also for the residents living in the close areas. It goes to the high sensitivity and selectivity. But also there was one issue that for some of this very recent inert fumigants, the detection level was not high enough. Here we also use the same approach because we can take the nylon. If you see the nylon fiber, there's an amide bound. And by using some kind of reaction, we can also add this DEAE and also build up this polycationic structures depending on the concentration the use of this DEAE and chemical in the treatment. Well, with this, see, this was our original approach that we were able to make this sensors using nylon-based paper-like structure. You see the color change. And also this is the range of the detections goes to 800 ppb, and you will see. But these are very effective against the methyl iodide, the methyl bromide, and those two we can detect to the 800 ppb. But once we move into so-called 1,3-dichloropropane, and the detection level was in the several ppm level. Now we have this new chemistry. We're able to add a kind of new structures because we have more positive charge built onto it, and this positive charges are able to catalyze the coloration reactions on this material because the material already have a kind of blue structures, but based on the additional catalytic effect, it can further interact with this target and will produce a brownish color. And also, if you are interested in this research, you certainly can look at this publication and search my name, my email, you will be able to see the full descriptions. But now I just show you a dramatic color difference and also the sensitivity change with these polycationic structures on, we call the cationized nylon nanofibers membrane structure, which is still paper-based, which is still the in the same type of the use, but which is way more sensitive. You will see if we have a kind of a color strip bar to indicate this the color intensity as a kind of indication of the level of exposure to the pesticides or the fumigants, the vapor here, and you're going to see it goes down to the 200 ppb, 0.2 ppm. And also you can repeatedly use for several times, although these are the disposables, but in the case here, we could make it into more reusable sensor, particularly for the residents. Well, with that type of approach, we wanted to go because we do see the polycationic structures, but also we see highly porous and also the high surface area materials would be also useful for improve this sensitivity and improve the function of our materials. Now we go for further. So we take this cellulose structure And also we use this cyanuric chloride, and then we build a cage. And this cage, we name it as a polymeric organic porous framework by reacting with the cyanuric chloride and together with the melamine. And this cage can be measured and in the porosity and also in the pore structures. Okay, and also when we use cellulose structure, now we are using bacterial cellulose aerogel structure. So if you ask how do we make it, actually it's still pretty simple. That if anyone used the bacterial cellulose, and you know that it's come out in the membrane structures, when you freeze dry, you form an aerogel structure. And now we run this simple reactions, only 2 steps. Once you graft this cyanuric chloride, and then secondly, you react with the melamine. The reaction is a little bit harsh on the use of this material, but we want to prove the concept of these structures. What is structures? It's very porous. We call the hierarchically porous structure, and with the super porous, because you see the bigger pores, and also mesoporous, a little bit more dense structures, and also goes to the even smaller pores built up by this type of the pulp structures. And well, with this structure, you definitely will see the pore width comes in the size of the very small areas, and also with the larger areas, and so on. But also you're going to see dramatic increase of in the surface area with adsorption, surface adsorption potential. So I'm not going to go read all these details, but if you are interested, this is just recently published on the Chemical Engineering Journal. Well, with this material, what happens is we're able to use it to really detoxify the chemicals and the pesticides or any kind of chemicals that are more interactive and trappable by this pulp structure. But we do have a very high surface area. And here shows you all the adsorption potentials for this. But I want to tell you that at the bottom, we use 3 different pesticides. It all demonstrated a huge, super powerful adsorptive function. And in the next slide, you're going to see more of these real practical applications. But here, it's all just showing you that the potential, and we have all different measurements. Theoretically, we can prove this high surface and the area adsorptive potential, and in the kinetically or thermodynamically. More interesting, the first author set up in using this material as a filter. So now you can run through the different liquid through it. You also will see the removal of this pesticide when the liquid runs through this. Well, now we demonstrated in the very practical applications. So what those are looking like is this would be the aerogel structures, and also very interesting. This due to those kind of pulp structure, it shows some kind of fluorescent anyway under the UV. And when we use it to wipe any type of those the fruits, now we all know that we have some of the kitchen cleaning devices and to wash off something, but now we can wipe it in the field. So when we wipe those, and obviously you're going to see we tested with the different pesticide, we spike the pesticides on it, you're going to see the complete removal. And also you could see for this methyl parathon, which is a common organophosphate, we even could use a kind of fluorescent signal to detect whether there's any kind of MP on your product, because the fluorescent signal can be viewed under this. And others we may not be able to see, but we can chemically and physically remove this. In this sponge structures is able to repeatedly use for many, many times. Here it's 20 times uses. Well, with these, I still don't want to stop because we want to make them into a real fabric. So now we have the fabric. And that was used for the bacteria sponge, which is a kind of expensive and rare material. Well, we demonstrate those things, but we also use it on the fabric. This is the real fabric. It's still run the same reaction. Okay, when we make this, and obviously you see the morphology changes in color is a little bit ugly, but still fabric. It shows this absorption functions. We can prove all the existence in the functions. So here, this is the demonstration of this. But the good thing is when we have such a kind of structure in this, it has a huge potential to absorb the real life, the chemicals, because this work was originally supported by our California's pesticide regulation department. And we try to remove the fumigants, which is the major concern for the farm, for the agricultural production. So now, and this structure is able to remove one of the representative of the fumigants, which is called the methyl iodide. Methyl iodide and methyl iodide, methyl bromide, and also 1,3-D are the typical fumigants widely used in California for growing the strawberry, and also used for the fumigant controls for crops and also for houses for termite controls. And obviously you see this, the absorption capacity without the cage, and you see the difference of the cotton with the cage, with the pulp structures, you're going to see dramatically increase. The good thing is it could repeatedly absorb. You obviously need to remove it, but you can reuse it and recharge it. Well, we also found out that if you leave it without recharging it for a certain time, and the material becomes yellow, and in fact, there's a chemical structure change. And that actually serve as an indicator, and with the showing of this amount of cumulatively exposed to the fabric, you see this. And we've realized this is the great benefit for the users, particularly the farmers, when they harness such a material in their houses and showing a cumulative exposure level of this fumigants in the field. And obviously this is the color indication, but this also shows that when the color reaches these areas, it will reaches a kind of a significant brownish. It reduces the absorptive functions to the fumigants. Also, we tested in different approaches, but I want to cut it short. I think the time is limited. Well, we still didn't stop it here. And also remember that we had the rose bengal trapped in the polycationic structures. We also demonstrated some kind of functions, the good function, but there's kind of a limitation. Now we use this cage, and also we can trap this rose bengal into the cage. But remember, the rose bengal is photoactive. And how do you prove it? And actually, we still see this, the UV spectra. We still see the material has a huge absorptive, powerful function. So we don't want to mess up with those kind of further demonstrations and prove this structure. But I do want to show you that this is the very interesting part that I showed you before, and this is a kind of image we had before. But now we do have detections of the reactive oxygen species. Again, you see this pink, which is the singlet oxygen. The gray actually represents another one, which is going by the type 1. And under this type of structure, those rose bengal produces the singlet oxygen under the same light of exposure. And also, interestingly, it has increased the production of the hydroxy radical, which is a representation of going for the type 1 mechanisms. And also, I can tell you that we have all the evidence showing the fluorescent structures. The very powerful evidence for this improvement is we still see here, but under daylight, this is just purely white light. What you see is that this is the antibacterial function. 5 minutes, and almost 2 log, 10 minutes, almost reach to such a log reductions, and the gram positive, gram negative. 20 minutes, you're going to demonstrate 6 log. Very fast and powerful, and also repeated antibacterial functions. You could run for many, many washes for this material. Okay, so I think there's no time, and I'm going to just stop here. In fact, we do have more in this area. So I demonstrated the cationic high porous structure, and also showing those cotton materials, other fibers that are able to demonstrate a very powerful, very interesting chemical, biological, sensing functions. And we use this for, mostly used for the fumigants, to detoxify the fumigants, and also some pesticides. And also we use it for those, some of the material can be really used as filter, as air filters, as a face mask material. This would be our cotton-based face masks, and for biological chemical protection, it would be multifunctional. So with those, and I want to end my talk and with acknowledgement for these funding agencies. This is just, from the USDA, from the National Institute of the Environmental Health Science, from the Center for Disease and Prevention, and also from California Department of Pesticide Regulations, because you do see that we covered overall area of the pesticides, and also now the face masks, and also human safety areas. Thanks for your attention. I would like to see any kind of questions from the audience. Thank you.
Okay, thank you, Professor. It was really an enlightening one. Firstly, I want to present your certificate. I don't know if you can see. When you come to Turkey, hope we can meet sometime and we can give it by hand. Yeah. Yeah, you can see here also. Can we have any question from the room, actually, from the hall? Actually, we are suffering from what you explained here, Professor, especially these pesticides on tomato. Actually, in our country, in Turkey, when we make some exports, generally the importing countries are complaining that these Turkish tomatoes do have a content, a pesticide content, actually, at some ratio. And you know, it really destroys our this import-export procedures a lot. My question is, using this, I mean, I believe you talked that as a textile wipe, and this wiping mechanism might remove these pesticides. Do you think the pesticides can already be penetrated through inside the fruit, tomato, and other things? I mean, wiping action, how we can remove all the pesticides that are on tomato?
I think the removal process is via the absorption, because we do have a highly porous structure. And as I demonstrated, there's 3 different porosity. Second one is these materials all bear a kind of a common feature that carrying very strong positive charge. And any of those anionic charged species would be strongly interactive. So, and many of the chemicals, when we wet, and also the dyes, and we know those, and some of the pesticides, many of those bacteria cells, they are very, when they are in a liquid form, and they all carry negative charge. So under this condition, they become very interactive with these materials. And also we will add this photoactive agent that becomes much more interactive and also intimate in the surface contact. So it provides the function, so the first one is adsorption, second one is a chemical interaction.
Interesting. I believe this study should be very important for Turkish exporters and agriculturists. Anyway, thank you very much, Professor. I believe we have one more question from Professor Ulpas.
Yeah, hi, Dr. San. This is Dr. Ulpas from University of Maryland at College Park.
Sorry, I couldn't hear. Could you?
Professor Ulpas from University of Maryland. Yusuf Ulcay.
Thanks.
I think hocam buradan
I
konuşuyoruz.
was the one who invited you, and because we met several times in the Fiber Society meetings. And your department chair also was graduating from our department at the University of Maryland and Ulpas.
Thank you. Thank you. I barely get to hear some. I really appreciate all the comments.
And please say my congratulations to your past director of the department, Ms. Chang.
Muhtemelen sadece salona geliyor. Ondan duyamıyor olabilir.
I think there is a problem with the microphone. Probably you can't hear the middle of the question.
I believe with questions we do have kind of misconnection. Many thanks, Professor, for being there at that time. I believe it should be early morning, even late night in California. Thank you very much. Hope to host you in Istanbul as well. Thank you.
Thanks. Thank you.
Our next speaker, I believe, is Dr. Aslı Balçak-Girgin. Yeah. So she has an interesting topic. Actually, the topics, as you know, the textile industry is kind of really wide. For that reason, we are really having difficulties to arrange them in under some subtopics actually. But anyway, we all guys are, I believe, somehow related with textiles, and this topic is also related to textiles. So Aslı's presentation is about the development of natural dyeing processes for cellulosic fabrics. I believe it is quite important for this sustainability century. So I believe Aslı already graduated from her PhD. Her doctorate and master's field is to propose a model for textile innovation system and to measure the R&D and innovation performances of R&D centers. Right now, she is working as a researcher in Harput R&D Center. So Aslı, this is yours. Thank you.
Hi, everyone. Development of natural dyeing process for cellulosic fabrics. First, content, company information, introduction, material method, result, and discussion, and conclusion. First, a little information about Harput Textile. Harput Textile is the flagship of the Harput Holding. Harput Textile, which has been producing over 180 million meters of fabric since 2008 and continues to serve 44 countries in 5 continents and world brands. Sustainable growth of the company brings it to the Fortune 500 list.
Excuse me. Can you share your screen, Dr. Balçak? We can see your presentation.
Can see.
We can. You need to share the screen in EBTX mode. That will not work.
Can you see now?
I can see, but this is not presentation mode. We see just the PowerPoint screen.
Kanıt almıştım. Bir dakika ben
Şunu mu seçmeniz lazım? Şu değil mi?
Can you see now?
No, still same.
Hmm?
Still same. This is not presentation mode, and when the
Now?
speaker, what? Okay, perfect.
How about now?
Okay, that's better.
Today, Harper Textile carries out different kind of R&D studies for the provide solution our customers in different technical textile markets. Introduction. Natural dyes structures obtained from various sources. They can be classified animal, vegetable, mineral dyes according to the source they are obtained from. Natural dyes contain different kind of chemicals, and two important groups of natural dyes are flavonoids and anthraquinones shown in Figure 1 and Figure 2. Mordants are substances that provide the fixation of the dye stuff to the material, improve the fastness properties, and give the differences in color. Most natural dyes cannot be permanently attached to the fiber. Mordants must be used for this. Natural dyes mix complex with the metal atoms and gain some substitutivity against the fiber and can color the textile fiber. It improves the fastness and increase the dyeing efficiency. Most of the natural dyes are mordantic dyes, and a few of them are the substantive dyes. There are basically three different mordantic methods. These are pre-mordantic, metamordantic, and post-mordantic. Pre-mordantic and post-mordantic require an additional step in dye bath, and metamordantic can be performed in a one step in a dye bath. Mordant materials can be used individually or mixed in the various proportion. After this mordantic substance are dissolved in the mordantic bed, and the metal ion is bound to the fiber by staying the proper time and temperature. The pre-mordantic method is generally preferred. Traditional dyeing methods, these methods save time and energy. Advantages of the natural dye stuff. Color tones obtained with natural dye stuff are generally soft tones. Very wide color palette can be reached by mixing natural dyes. The use of same dye stuff and different mordant can change the color and enables the new color to be obtained. Gray colors can be obtained with natural dye stuff. The basic raw material of synthetic dyes is not renewable. Natural dyes are generally renewable and plant-based, also biodegradable. The use of natural dye stuff will reduce the use of petroleum-based synthetic dyes. The content of natural dye stuff is anti-allergenic, protects the skin, does not show any dangerous properties for human health. While some of the natural dyes stuff give brighter colors in time, the synthetic dyes fade in time. And let's look at the disadvantages of the natural dye stuff. It's difficult to obtain same color over and over because natural dye stuff agriculture area of plants seasonal change, species-related differences, and the maturation periods do not allow this situation. It's difficult to obtain standard recipes for using natural dyestuff. The low color yield of the natural dyestuff source requires use of more dyestuff. There is also long dyeing period, mordant agents, and certain cost of mordanting. Color change may occur when the dyed textile material exposed to sunlight, perspiration, and air. Except for a few natural dyestuff, they are bound to the material with mordants. Material and method. In the study, yellow dyestuff represents light color and red represents dark colors. In dyeing process, 8 different cellulosic fabric qualities were used. These are tencel, cotton tencel, poplin, viscose, cotton, linen, viscose blends, and 100% cotton fabric in different qualities. In the study, after pre-mordanting, white processing dyeing with natural dyes was performed. After application, washing and drying process was performed. Wet and dry rubbing test, pH measurement, and washing fastness tests were performed in the sample fabrics. The second mordanting process was carried out in dark colors twice. Here are pet batch dyeing process step. Laboratory scale dyeing process was carried out. The solution prepared with 50 gram per liter mordant was impregnated to the sample 6 passages in the pet batch sample machine and kept for 1 hour. Then the sample rinsed and with cold water 3 passages. After rinsing, drying was done, and then fabric were ironed. In the dyeing process, 10 gram per liter natural dye stuff, 10 gram per liter dispersion agent, 5 gram per liter soda was impregnated to sample 6 passages. Then samples were stretched and kept for 1 hour. Dark colors were more than twice. Result and discussion. In the first process, it was observed that inhomogeneous dyeing was occurred due to the wrinkles of the sample. Therefore, dyeing process was repeated and optimized. In order to eliminate dyeing defects caused by fabric fracture, 8 different cellulosic fabric qualities were ironed and mordanting, and same recipes was applied again. It was determined that fabrics in light colors dyed homogeneously according to result of washing and rubbing fastness test. The fastness of dark colored samples fabric not enough. Significant irregularities were detected in the dark colors. And here are fastness to rubbing and pH values in table. Y1 and 8 represent a sample in yellow, dyed yellow. R and R2, 8 represent a sample dyed red. While the red rubbing test values in light colors remain low, higher values were achieved in the dry rubbing fastness. While the wet rubbing fastness values in dark colors were quite low, rubbing fastness values were below in desired volume. The pH result of dyeing samples were in the range of 6 and 7, as expected. Here, fastness to washing values in light and dark colors, while washing fastness values in the sample dyed in the light colors were high, and washing fastness values of dark color fabrics were lower. Conclusion, within the scope of the project, using open white technique for cellulosic fabric qualities, purse mordanting, and different kind of dyeing recipes were applied. Results were evaluated. Double mordanting was performed for dark colors. After dyeing, fractures were detected in the fabrics. This shows that after mordanting and before dyeing, the fabric must be prefixed with the standard process. According to results, process steps were optimized with the study. Existing disadvantages was eliminated, and better results were obtained. In this project, homogeneous dyeing was achieved with light color and dye stuff and the pro-mordanting method. Commercial natural dye stuff contain impurities. Even high temperature dye stuff that don't completely disperse in the water phase and leave residues 50 or 20%. As the color darkness increase, dyeing error increase, and fastness decrease partly. It's possible to obtain color change or increase the color darkness with the different mordant substance in same natural dye stuff. It was seen that reactive dyeing process is impractical and more costly, and reproducible color tonnage could not be achieved. In future projects, improvement of process in dark colors are considered. According to interviews, supplier company and reviewed literature, HD tube dyeing method has been chosen for future studies. Thank you for your attention.
Very nice study. Yeah. İlk önce let me give your certificate for attendance. Aslı hocam. Very interesting study. Is there any question from the room, my friends? Or from the, I don't know, the guys who are attending to Zoom? Sir.
Thank you very much. Thanks a lot. It was very interesting. You know, for the natural dyes, we've got three problems. One is, if it's from plant origin, we need to use lots of water for them, for irrigation, then fertilizer, then pesticides, which are all polluted. The next problem is that the mordant problem, which is a toxic wastewater. It produces toxic wastewater, so we are not allowed to use that. And the third one is the price. Do you think it's going to be something to use it in the industrial scale?
Of course,
just for hand
because there's a lot of need for organic qualities, and reactive. I think reactive dyeing prices is 5 to 55 euro in the markets, and natural dyes 45 too high. I don't know the upper value, and but you can sell this products very added value. You can give it in very big add value, and you can sell it. And we can make different kind of process for this. We work for it in here. Our working is going on.
That's very excellent, but you know, usually natural dyes are allowed to be used in some places with a very good wastewater treatment plant with low wastewater site. Because if it goes to the environment, the metal is going to be very toxic. So I don't know if it's in industrial scale, you ever talk about this or not? Because it's not something that everybody can use it, is it? Because they're going to be a danger for the environment.
Pesticides can be used different kind of products for our eating. Our every type of pesticide can be used, every kind of product, and the solution for pesticides must be fine for all of them.
Okay, many things you can discuss later, Aslı hocam. This is also one more gift from our, so everyone should present something to get our cups. Okay.
Thank you.
Let us take our next speaker, Zeliha Çavuş hanımefendi. Zeliha Hanım, is it gonna be Turkish or? Okay, no worries. I hope we will end up with this online version, so there won't be any more problem. Galiba oydu. Bu musun? Evet. Sen hemen kapatmaya çalıştım. Ben hayat hikayesini kullanmak istedim. Uzuma geçeyim.
Ömer Hocam sen ekran paylaşabilirsin.
Zeliha Hanım lisans eğitimini Ege Üniversitesi'nde tamamlamış. Daha sonra da Bahçeşehir Üniversitesi'nden biz de orada bir ders verdik değil mi? Hatırladım. Teknik Tekstil bölümünde tamamlamış. Şu anda da Şişmanlar Tekstil'de Ar-Ge merkezinde. Zannediyorum Türkiye'nin herhalde en büyük mü? Şitex grubu, Non-Woven grubu üzerine. Ar-Ge merkezinde Ar-Ge yöneticisi olarak görev yapmaktadır. Reklam da yaptım. Gelecek sefer sponsor olursunuz artık. Bugünkü sunumunun konusu polyester elyaf özelliklerinin otomotiv kullanımında akustik ve mekanik özellikleri etkisinin analizi. Zeliha Hanım buyurun.
Ekran geldi mi?
Evet, gayet iyi.
Herkese merhaba. Bugün sizlerle polyester elyaf özelliklerinin otomotiv dış trim parçalarında, dış trim parçalarında kullanılan malzemelerde akustik ve mekanik özelliklere etkisinin incelenmesi ile ilgili yaptığımız çalışmayı paylaşacağım. Sunumda ilk olarak kısa bir firma tanıtımı olacak. Daha sonra çalışmamızın amacı, otomotiv tekstilleriyle ilgili genel bir bilgi, kullandığımız malzeme ve yöntemle ilgili bir bilgilendirme yapacağım. Son olarak da sonuçlar ve genel değerlendirmeyle sunumumu sonlandıracağım. Şişmanlar Tekstil Hassan Grup bünyesinde bulunmaktadır. Hassan Grup Türkiye'nin önde gelen dokunmamış kumaş üreticilerindendir. Üretiminde tamamen nano üretimi üzerine odaklanmıştır. Bünyesinde bulunan şirketlerde otomotiv, beyaz eşya, hijyen, medikal, konfeksiyon, jeotekstil ve mobilya sektörlerine hizmet vermektedir. Tekstiler Tekstil Hassan Grubun ilk firmasıdır. Kendi bünyesinde bulunan tarak, havalı serme, ısıl ve mekanik bağlama gibi farklı üretim teknolojileriyle 300 GSM'den 3500 GSM'e kadar değişen gramaj aralıklarında üretim yapabilmektedir. Bünyemizde sentetik elyaf, doğal elyaf, cam elyafı gibi orijinal ham maddelerin yanı sıra kendi bünyemizde tekstil atıklarının geri dönüşümünden elde ettiğimiz elyafları da kullanmaktayız. Geri dönüşüm elyaf kullanımı ile hem çevreye duyarlı hem de ekonomiye katkı sağlayan bir üretim yöntemi benimsemiştir. Firmamız otomotiv, yatak, mobilya, beyaz eşya ve inşaat sektörlerinde ürün çalışmalarını devam ettirmektedir. Bu çalışmamızda çevreye duyarlı, geri dönüştürülebilir, yüksek akustik ve mekanik performansa sahip otomotiv dış trim parçalarında kullanılabilecek tekstil yapılarının geliştirilmesinde elyaf özelliklerinin ürün özelliklerine etkisini incelenmesi hedeflenmiştir. Otomotiv tekstilleri teknik tekstiller içerisinde oldukça önemli bir alana sahiptir. Geleneksel malzemelere göre daha hafif olmaları, yüksek akustik ve termal izolasyon sağlamaları, kolay şekil alabilmeleri ve aldıkları şekli muhafaza edebilmeleri gibi avantajları sebebiyle otomotiv sektöründe oldukça önemli bir kullanım alanına sahiptirler. Ortalama bir araç içerisinde 2000 yılında 20 kilogram olan teknik tekstil kullanımı 2020 yılı itibariyle 26 kilograma kadar ulaşmıştır. İlerleyen yıllarda kullanım miktarının 35 kilograma kadar ulaşması beklenmektedir. Şu anda yaklaşık 40 farklı parçada teknik tekstil kullanımı bulunmaktadır. Bu alanda otomobil iç bölümlerinde taban halısı, şapkalı keçesi, ön göğüs izolatörü gibi parçalarda, kapı panellerinde, bagaj bölgesinde bagaj halısı, bagaj tabanı ve bagaj yan parçalarında kullanımlar bulunmaktadır. Son dönemlerde artık dış trim parçalarında da tekstil yapılarının kullanımı gözlenmektedir. Bu alanda çamurluk keçelerinde, araç altı kaplama, motor altı kaplama gibi bölümlerde de plastik parçalar yerine tekstil yapılarının kullanımı artmaktadır. Tekstil yapılarının tercih edilmesinin en önemli özellikleri akustik performanslarının yüksek olmasıdır. Günümüzde teknolojik gelişmeler ve artan müşteri beklentileri sebebiyle araç üreticileri ergonomi, güvenlik, yakıt tüketimi, sürüş konforu, ses ve titreşim alanlarında kendilerini sürekli geliştirmeye çalışmaktadır. Rüzgar sesi, yol sesi, lastik sesi, motor sesi gibi sesler araç içerisinde sürüş konforunu önemli ölçüde etkilemektedir. Araç içerisinde sürücü ve yolcuları etkileyecek, akustik konforu bozacak farklı ses kaynakları bulunmaktadır. Bu kaynaklarda oluşan sesler yapısal yolla ya da hava yoluyla iletilmektedir. Farklı frekans aralıklarında etkili olan bu seslerin önlenmesi amacıyla araç segmentine ve uygulama alanına bağlı olarak farklı özelliklerde ürünler kullanılmaktadır. Bu noktada çalışmamızda da bizim odaklandığımız dış trim parçalarındaki tekstil uygulamalarına baktığımızda ağırlıklı olarak çamurluk bölgesinde, araç altı kaplama, motor altı kaplama bölgelerinde plastik parçalara alternatif olarak geliştirilen, plastik parçaların ve tekstil yapıların birlikte kullanıldığı hibrit parçalar ve tamamen tekstil yapılı malzemeden üretilmiş parçalar bulunmaktadır. Tekstil yapılarının plastik yapılara göre %30-%50 oranında daha hafif olması, akustik performanslarının daha yüksek olması gibi avantajları sebebiyle bu değişimde önemli bir rol oynamaktadır. Çalışmamızda kullandığımız malzemelerden bahsedersek, malzemelerimizde takviye malzeme olarak pet şişe atıklarından geri dönüştürülmüş polyester elyaf kullanımı yapıldı. Burada farklı inceliklerde polyester elyafın ürünün form almasını sağlaması amacıyla sheet and core yapıdaki bir komponent elyaflarla karışımından elde edilmiş yapılar kurguladık. Toplamda 6 farklı numune grubuyla çalışmamızı sürdürdük. İlk 3 grupta 13 Ditex, 6.7 Ditex ve 3.3 Ditex polyester elyaf kullanımı oldu. Daha sonraki 3 grupta ise bu yapıların ikili karışımları halinde kullanımlar gerçekleştirdik. Numunelerimiz tarak, çapraz serme ve iğneleme yöntemi kullanılarak nanoun formunda endüstriyel koşullarda hazırlandı. Daha sonrasında nanoun formunda hazırlanan malzemeler Pelzer Pimsa firmasında ön ısıtma, soğuk kalıplama yöntemiyle 4 milim kalınlığında levha formuna getirilmiş ve kullanım amacına uygun olarak özelliklerinin belirlenmesi hedeflenmiştir. Akustik ölçümler Ar-Ge merkezi bünyesinde bulunan empedans tüpüyle ISO 10534-2 standardı kullanılarak ses tutum katsayıları ölçülmüştür. Mekanik test sonuçlarında ise firmamız bünyesinde bulunan üniversal test cihazıyla kopma mukavemeti ve uzama tayinleri gerçekleştirilmiştir. Çalışmamızın sonuçlarını değerlendirdiğimizde beklendiği üzere elyaf inceliği arttıkça mekanik performansların arttığı fakat uzama sonuçlarında bir azalış gözlemlenmiştir. Bu noktada bizim hedefimiz beklenen, bizden istenen araç segmentine uygun bir çözümün hangi elyaf denyesiyle sağlanabileceğini belirlemekti. Bu noktada karışımların tek başına kullanımlardan daha iyi bir performans verdiği değerlendirildi. değerlendirildi. Parçadan yüksek mukavemet beklentisiyle birlikte formlama işlemi sebebiyle belli bir uzama değerine de sahip olması bekleniyor. Parçalar levha formuna getirildiğinde karışım seçeneklerinin numune 4, numune 5 ve numune 6'da hem mekanik mukavemetlerinde belirgin bir artış gözlendiği hem de uzama değerlerinde güzel sonuçlar elde edildiği görülmüştür. Akustik performanslarda namlu formunda değerlendirdiğimizde genel olarak benzer performanslar gösterildiği, düşük frekanslarda benzer performanslar gösterildiği, 1250 Hz'den sonra ise elyaf incelikleri azaldığında akustik performansın arttığı görülmektedir. Plaka formunda ise yine düşük frekanslarda benzer performanslar göstermelerine rağmen 1250 Hz sonrasında karışımların tek kullanımlara göre daha iyi performans gösterdiği gözlenmektedir. Sonuçlarımızda 6 farklı harman ile hazırlanan numuneler değerlendirildiğinde elyaf inceliği azaldığında malzemenin mukavemet değerlerinde artış gözlenmektedir. Uzama sonuçlarında ise elyaf inceliği azaldığında uzama miktarları da azalmaktadır. Parçanın form yapısı ve kullanım yeri düşünüldüğünde hem mekanik özelliklerin hem de belli bir uzama beklentisinin olması sebebiyle orta ve düşük elyaf inceliklerinin birlikte kullanılmasının daha olumlu sonuçlar verileceği değerlendirilmiştir. Akustik performansta ise empedans tüp ölçüm sonuçlarında bahsettiğim gibi düşük frekanslarda tüm numunelerin benzer performans gösterdiği, 1250 Hz sonrası için ise düşük elyaf inceliklerinde daha iyi sonuçlar elde ettiğimiz görülmektedir. Devam eden çalışmalarda farklı elyaf inceliği dışında farklı elyaf kesitlerinin de malzemenin mukavemet ve akustik performans üzerinde etkisinin incelenmesi hedeflenmektedir. Bunun dışında ayrıca tekstil atıklarından elde edilmiş karışık elyaf inceliğine ve uzunluğuna sahip polyester elyaf kullanımlarının da parçanın akustik ve mukavemet performansına etkisi incelenecek. Pet şişe atıklarından elde edilen elyaflara göre performansı değerlendirilecektir. Çalışmamızda bulunan kaynaklar. Beni dinlediğiniz için çok teşekkür ederim.
Thank you very much Zeliha Hanım.
Thank you.
Yarı Türkçe, yarı İngilizce artık diyoruz. Neyse. Sorusu olan var mı Zeliha Hanım'a? Ali Hocam'ın sorusu var.
Teşekkür ediyoruz sorunun için. Özellikle ses sınıfına kaç sayısı üzerinde bir çeşitten bu sorunun işini nasıl değerlendiriyorsunuz? Nereden kaynaklanıyor? Orada bir yorum yapabiliriz.
Lif uzunluğuyla ilgili bizim kendi bünyemizde yaptığımız çalışmalarda geri dönüşüm elyaflarda gördüğümüz farklı uzunluklardaki malzemelerin birlikte kullanıldığında daha iyi performans verdiği yönünde. Ama direkt belli bir incelikte ve belli bir uzunluktaki elyafta devam eden çalışmalarda bununla ilgili bir sonuç bekliyoruz. Ama ben kendi adıma şu ana kadar gördüklerimden kesit ve inceliğin uzunluktan daha önemli bir kriter olduğunu görüyorum. Bir sonraki çalışmamızda belki bununla ilgili de bir değerlendirme yapabiliriz. Ama şu anda elimizde sağlıklı bir veri yok bunun için.
Çok teşekkür ederim. Salonda var mı yorum yapmak isteyen bir uzunluğu konusunda? Hocam buyurun.
Duyuyorum.
Neyi merak ediyorum? Çünkü bilgisayar keçe uygulamaları var. Gereksel uygulamalar. Onlara göre bir fark gördünüz mü? Mesela şu an için elektrikli araçlar çok önde.
Evet.
Onların teknik isterlerine göre bir sonuç elde etmiyor.
Evet, bu parçalar zaten şu anda hali hazırda otomotiv endüstrisinde kullanılan parçalar. Sadece her araç üreticisi farklı bir beklentiye sahip. Araç segmentine ve firmanın yapısına bağlı olarak farklı bir beklentiye sahip. Özellikle dış trim parçalarında istenen akustik performansları plastik parçalara göre çok daha iyi bir şekilde sağlayabiliyor. Ağırlıklı olarak şu anda yurt dışında 3 segment araçlarda hibrit parça kullanımının yerine tamamen tekstil yapılı parçalar kullanıma başladı. plastik parçalara göre hem ağırlık azaltmada hem de akustik performansta yaklaşık olarak %30 ile 50 bandında bir artış sağlayabiliyor.
Şimdi yeni elektrikli araçlarda ses olmayacak diyorlar.
Motordan kaynaklı bir ses olmayacak ama motor sesi kesildiği için özellikle dış kaynaklı seslerin içeriye yansıması ile ilgili geleneksel araçlara göre daha fazla izolasyon parçasına ihtiyaç duyacaklar. Evet, yani özellikle dış taraftan gelen sesler için motor sesi kesildiği için aracın içerisine özellikle lastik sesi, yol sesi gibi sesler daha fazla gelecek. O yüzden ağırlıklı olarak çalışmalar biraz daha dış parçalar üzerinde artmaya başladı şu anda.
Okay, thank you very much. Size de kupanızı verelim.
Teşekkür
Size de
ederim.
alın, buyurun. Hatıra öyle. Sponsor olarak bekliyoruz dediğim gibi. El Hayat eski dostum burada yok galiba ama kendisi Etiyopya'dan bir vatandaşımız bizim yine. Doktorayı burada yapmıştık. Zannediyorum katılmayacak. Sıradaki arkadaşıma Associate Profesör Doktor Fatih Suvari. Fatih Hocam dışarıda mısın aslında? Seni niye buralarda göremiyoruz?
Online hocam Fatih.
Değilmiş hocam ya. Almanya'da mı?
Online görünüyor.
Online Almanya'ya yakın oldu. Fatih Hocam gelseydin buraya şey yapardık, iyi olurdu. Neyse online dinleyelim Fatih Hocam'ı. İngilizce mi yapacaksınız hocam?
Hocam duyuyor musun acaba?
Evet duyuyorum. Sen
Ha.
beni duyabiliyor musun Fatih Hocam?
Ha, evet hocam şimdi alabildim. Evet hocam İngilizce.
Are you gonna... okay. Dr. Suvari is working as an associate prof in Textile Engineering Department of Bursa Uludağ University. His research field is on the design of acoustic fabrics, fiber production technologies, and nonwoven material designs. Fatih Hocam, we are listening to yourself.
Okay. Thank you for the introduction. Okay, I'm ready. Hello, everybody. In this presentation, I'm going to talk about some special woven fabrics which show auxiliary behavior. We produced these materials with elastane containing braid yarns in the weft, and the weft yarns were inserted into the fabric with tension and without tension. And this work has been supported by the TÜBİTAK project, and I am one of the researchers in this project, and my colleague Dr. Mina Akgün is the responsible person for the project. In this study, we investigated the changes in Poisson ratio of some special fabrics. We also checked their possible auxiliary performances. We used braid weft yarns containing elastane in the weft, and these yarns were inserted with minimum tension, which we call slack, and with tension in the formation of woven fabrics. For the warps, for one group of fabric, we used braid yarns, but without elastane. For other groups, we used conventional polyester textured yarns, and air permeability and percentage of the wet area of these fabrics were measured. After producing the fabrics, we get special surfaces similar to the terry-woven structure, especially when the braid yarn containing elastane was inserted into the fabric with minimum tension. So what is Poisson ratio? Poisson ratio is the negative ratio of transverse deformation to longitudinal deformation in materials. Materials with a negative Poisson ratio are called auxiliary materials. When you apply force in one direction, you get expansion in the auxiliary materials. But for the conventional materials, on the other hand, when you apply force in one direction, you get contraction. The width decreases, in other words. So auxiliary materials have some increased mechanical properties. They have variable permeability, which we use it in textiles especially, and they may have also increased acoustic absorption, and all these properties make auxetic materials better than conventional materials. In textile, we can use these auxetic fabrics, especially in clothing comfort applications. For example, normally while doing sports, when force is applied to your clothes, pores get smaller. But in auxetic fabrics, pores become bigger when deformation is occurred during sport activity. So sweat and heat can leave the body easily. Another application, for example, agents can be released easily by stretching the fabrics in the area of medical textiles. Another interesting application, for example, in filtering, when extra pressure is applied to structure, pores become bigger, and bigger pores of the auxetic structure have to decrease the pressure acting on the filter. In one of our published work, we used braid weft yarns, and we get an auxetic behavior. In another study, we used only elastane yarns in the weft, and again, we get an auxetic behavior. For this study, we used braid weft yarns containing elastane. So here again, we expect to get auxetic behavior. This is our experimental setup. We have two fabric groups. In one group, we used conventional polyester textured yarn as warp. For the group B, we used braid yarns but no elastane here. For all fabric types, we used elastane containing braid yarns in the weft, but for the A1 fabric, we sent the weft with tension. For the A2, we inserted the weft into the woven fabric with minimum tension, which we call it slack weft. For the B1 fabric, again, we sent the weft with tension, but for the B2, we sent the weft with minimum tension into the fabric. This is the machinery in our laboratory in Textile Engineering Department of Uludağ University. We produced braid yarns with this machine. Polyester and elastane textured yarns were used as the component to form the braid yarn, and 8 sheet yarns were used to produce the braid yarn with elastane. Here we can see the images of the braid yarn that we produced. At the left image, everybody, here the braid yarn is in the relaxed form. There is no force acting on the weft, on the yarn, so it's in the relaxed form. But as you see, it is a little bit bulky. The appearance is totally different than the right image. In the right side, after applying force, the braid yarn becomes like this. As you see, the appearance is totally different, and the bulk, there is no bulky structure, actually. So there is a very big difference in the appearance. So we decided to see this effect on the fabric. That's why we used this braid yarn in the slack weft form and with the tensioned form in the fabric. We produced all these fabric by the hand weaving loom. This is the images of the A1 fabric. Here we used conventional warp yarns, conventional polyester warp yarns, but in the weft, we applied force while inserting the weft yarns. And actually A1 fabric looks like conventional woven fabric. There is nothing special about it. But for the A2 fabric, minimum force was applied to weft yarns during weaving. As you see on the screen, we have a bulky structure here. So this fabric looks like terry fabric actually. And for the B1 fabric, again, conventional warp yarns were used and force was applied to weft yarns during weaving. And again, B1 fabric looks like, conventional woven fabric. Here for the B2 fabric, minimum force was applied to weft yarns again. So we have a big crimp in weft direction. And again, the structure is bulky here. This is the Shimatsu tensile testing machine. Here we measured the Poisson ratios with this setup. Here, there are markers on the fabric, everybody, and when we pull the fabric, the distance between these markers changes. So we detect this change by the camera and the software. Also, we developed that software. We used image processing methods, and we have also publication about the method. We measured the Poisson ratio by detecting the distance change between these markers, and we calculated the Poisson ratios. Air permeability, the fabrics were pulled for different elongation values in the tensile testing machine. And then after obtaining the certain elongation value, we stopped the machine and then we fixed the fabric to a frame. After that, we measure the air permeability for the extensions of 5 mm, 10 mm, and 20 mm. And measurement of the percentage of the wet areas on the fabric. Here, water was dripped onto the fabric pre-state under 5 mm extension, 10 mm extension, and 20 mm extension. And then the image of the dripped liquid was recorded. The appearance of the liquid when it was dropped onto the fabric surface was again processed with MATLAB. So let's look at the results here. As you see, the A1 fabric, we have negative Poisson ratio here. What does it mean? When you apply force in warp direction, the width increases. This is very interesting behavior actually. This fabric is, exotic fabric, because when you pull it, the width increases. For the A2 fabric, another interesting behavior, everybody, because when you pull this fabric again, the width doesn't change. Although you pull it, the width doesn't change, remains the same. Another interesting behavior, but these are the behaviors that we expected actually. Because, we used slack weft and we use braid weft yarns with elastin, and they have real high crimp. For the B fabrics, B1 and B2, we couldn't get negative Poisson ratio, although we expected. We couldn't get. The reason is, since we used thick and solid warps for the B fabrics, we used thick and solid warp yarns for the B fabrics. Probably this braid yarn, solid and thick braid yarn, prevent the fabric to expand in the transverse direction. But for the A1 and A2, we used conventional warp yarn. So these yarns allow the fabric to expand in the transverse direction, I think. Here, A2 fabric is special, as I said before, because, as I said, there is no significant change occurred in the transverse direction when you apply force. In the A2 fabric, we used select weft yarn, as I said, and the structure looks like terry fabric. Let's look at the air permeability results. For the A2 fabric, there is an increment trend because, you know, at free state, the air permeability is around 100, but for the 10 millimeter extension, the air permeability reaches 200. So there is an increment trend until 10 millimeter extension for the A2 fabric. And for the A2 fabric, we used slack weft. For the B2 fabric, here again, we used slack weft and air permeability increases as well. So A2 and B2 behave similarly. When you pull them, the air permeability increases. Actually, everybody, when you pull conventional fabric, air permeability normally decreases. So A2 and B2, that's why they are special, because air permeability increases. For the B1, you know, air permeability doesn't change at all. There is no significant change actually. We think that of the porosity of the A2 and B2 fabric increases when you apply force to these fabrics. Evaluation of the percentage of the wet areas. Here, everybody, for the A2 fabric, again, the percentage of the wet area doesn't change at all until 10 millimeter. We can see similar behavior from the B2 fabric. The A2 and B2, we used slack weft, which means we inserted the weft with minimum tension. So here again, the wet area doesn't change at all until 10, of course, until 10 millimeter extension. So the behaviors similar for the A2 and B2 fabrics, but for the B1, the behavior is totally different. Let's look at the images. Here, the first image, the A is, you know, free state. The B image is, you know, we applied force and the extension is 5 millimeter. The C is the 10 millimeter extension and 20 millimeter extension images. So as you see on the screen, the water area doesn't change much until the 10 millimeter extension, because, you know, the A2 fabric has a 0 Poisson ratio. So when you apply force, the structure doesn't change much. That's why the area of the water doesn't change either. For the B1 fabric, the scenario is different because, you know, in the warp here, we use braid yarns with no elastan, and the wefts were inserted with tension. So the fabric is under stress. Moreover, we apply extra force to get 5, 10, and 20 millimeter extensions. So the fabric has a very high stress. This makes the water drop to move easily somehow. So we get an increased area until 10. For the B2 fabric, again, here we used slack weft. So the weft was inserted with minimum tension. Similarly to A2 fabric, here the area of the water doesn't change at all until 10 millimeter, but somehow the area decreases when you apply 20 millimeter extension. So we should work on this wetting subject a little bit more, I think. Let's look at the sound absorption values. Everybody, since we produced A2 fabric, this A2 fabric, as I said before, it's a bulky structure. The fiber surface area, total fiber surface area of this fabric structure is really high. Moreover, the fibers are free. You know, they are not under stress, so they're free. So these fibers can have, you know, they have more chance to interact with the sound wave since they are free and the surface area is really high. So we expect to get high sound absorption coefficient, and as you see on the screen, the red curve, we get better sound absorption results than the conventional materials from the A2 fabric. As you see on the screen, we have this is not a bad value for a woven fabric actually. As a conclusion, when you use conventional warp and braid yarns with elastan in the weft, you can get negative Poisson ratio values and also zero Poisson ratio values. And if you use the weft in Slack form, you can get zero Poisson ratio and you can produce a terra-like structure. And this structure has, improved sound absorption coefficient values actually. These are our main results. So for the future work, we plan to produce these fabrics in industrial weaving machine. And we need to actually produce more fabrics and we need to do more tests for better understanding actually. Thank you for the attention, everybody. These are the references.
Fatih Hocam teşekkür ediyoruz. Yani senin sertifikanı yansıtalım eğer mümkünse arkadaşlarım. Ben de buradan böyle göstereyim elimde. Ama Yusuf Hoca'ya verecekmişim. Kupa da burada böyle görüntü olarak.
Hocam
Onu da Yusuf Hoca istedi.
kupayı da Yusuf Hoca'ya verirseniz.
Allah kalsın, evet. Fatih Hocam'a sorusu olan var mı arkadaşlar? Yes, Dr. Bidoki.
Thank you so much. Thank you so much for it. It was very nice research. I cannot understand why the fabric is going to expand in the left direction to show a negative Poisson ratio. And I think, wasn't it because of the buckling of fabric when you stretch it from the warp side? Is buckling happens in the warp direction or not? Because for the structural point of view, there is no reason for the fabric to be expanded from the web side, or I couldn't imagine why it is expanding. So can you explain it to me, please?
Ali Hocam, ben maalesef duyamıyorum açıkçası. Çok az geliyor ses. Siz acaba şey yapabilir misiniz?
You can ask your question.
Çok özür dilerim ama duyulmuyor maalesef hocam.
Sorry, Professor. My question is that when we are stretching a fabric, especially from the bias direction, 45 degrees centigrade towards warp or weft, the fabric buckles usually, okay? And in buckling, we see a stretching from the weft side. But in your case, it was stretching from the warp side, and the fabric was expanding from the weft side. So what was the real reason behind this expansion? Because the structure, to me, was not in such a way to expand when it stretches from the other side. So can you explain it to me, please?
Okay, thank you for the question. Actually, after production of the fabric, these weft yarns contains braid yarns, but they have elastin. So just after the production, the width decreases very much because the weft yarn contains elastin. So when you apply force to warps, since the contraction from the width is very big, the force makes the wefts, to get, a little bit increase. Because, just after the production of the fabric, the width decreases a lot. So when you apply a little bit force in warp direction, the width suddenly, increases. This is the thing that we detected during the measurements, actually.
Thank you so much. Yeah, I got it now.
Okay. So our next speaker is from our one of our supporters actually for this conference. Our gold sponsor Innovenso is going to make presentation on year last advances.
Hocam internetten yeni indirdik de. Ömer hocam görüntü geliyor mu?
Hocam geliyor fakat yine sunum modunda değil.
Sunum modu şu an.
Hayır.
Tamam, bir dakika.
Şu an sunum modunda fakat yanında notlar gözüküyor ama sorun yok. Yani bu şekilde devam edebiliriz.
Bir dakika. Şu an nasıl? Yine mi şey oldu?
Evet, aynı oldu.
30 saniyede inşallah çözülür.
Şu an hangi modda ekran? Uzatma ikinci ekran modunda mı?
Şu an
Evet, şimdi oldu.
sadece sunum gözüküyor değil mi?
Evet, sadece.
Hala da ilerletebilirim. Hello, everyone. Thank you so much for joining this symposium. My name is Bushra. I'm working as a sales and marketing specialist at Innovenso Technology. And today I will be happy to introduce our company and our services. So as a company, actually, we have established our academic activities back in 2007. And then later on, we have officially established Innovenso Technology actually in 2010. So we are actually a manufacturer of electrospinning and electrospraying devices. Apart from that, we are offering R&D services for our clients. We actually develop these electrospinning and electrospinning machines from lab scale to the industrial scale products. So what we eventually do is that we have 3 modes of services. First, as I mentioned, we are manufacturer of electrospinning machines. And then we have R&D services that are covering product development, proof of concept studies, and contract manufacturing. I will definitely give you more details in upcoming slides. So lastly, we have contract manufacturing. We are developing your material, and then later on, once you order it, we can monthly or yearly produce it for you and share it with you. So when we come up to electrospinning and electrospray machines, it's starting from very entry lab scale machine all the way up to advanced scale machines and then industrial scale. So we are having a hybrid electrospinning technology, which is our patented technology. What is hybrid electrospinning? So you will see in the next slide that we have, let me show you, we have a different style of a nozzle.
As you can see, it is a conical shape designed, which will allow you to have multi-jets coming up from tip of the nozzles. So it is differentiated from standard nozzles that are available in the market just because it gives more production rate. Also, you can obtain more fiber jets at the end of the production. Also, these nozzles can be used after your process. You can clean it with the actually solvent that you use at the end of the electrospinning process. So we are coming up to the industrial scale production. Right now, we are offering two actually different technologies as Innovent. So we have offering hybrids, which is a needle-based system, as you have seen in the previous slide. And we are offering open surface technology, which is a needle-free technology. So our machines are very easy to use. They're all plug-and-play systems, and all of them can actually run for the long shifts. So I'm coming up to the hybrid electrospinning machine types. You see that this is a standard basic electrospinning setup that we are offering for industrial scale clients. You see that there are rolls and you can see many nozzles on it. So basically each nozzles can contain 27 nozzles. It's depending on the model for sure. So now we're coming up to open surface electrospinning. This is our newly technology. As I mentioned, it's a needle-free systems. So in some specific polymer types, it can increase the production rate up to 15 times compared to needle-based systems. So it is giving you more production rate. Sorry, I'm going to show you. So this is our string spinning 1000. This is a needle-free system. So you see that we have a actually substrate that is rollable and you can place it in a machine. So all the parameters can be controlled via tactile screen and it is very easy to use. So you can control everything. So it has 1000 millimeter width of the roll, and this is a very actually good machine for you to actually have more production. So maybe I'm going to skip these parts. So yeah, I mentioned these types. So I'm coming up to the production rate and capacity. You can see there are some standard polymers that we all use in this electrospinning field, and we have the capacity plus the total production rate here. You can see that TPU, PVDF, PA6, HA, and PEN, and PHP. So we have certain flow rates, and then we have the total production rates for 0.5 GSM. So if you would like to learn more about these production rates, you may contact us at sales@innovenso.com, so we may help you with all these technical details if you require. So right now we are coming to the NE series, which is our most advanced lab scale machines for versatile R&D research. So they're all user friendly, and of course customization plus upgradability are possible. For example, if you would like to have a temperature control or humidity control, because some certain application areas such as biomedical applications, you might need actually the temperature and humidity control, and some of our clients might require negative voltage too, so you may upgrade the machine for actually scalability. So our machines are designed for scaling up as well. So if you obtain a lab scale equipment, you can easily go up to pilot scale production, and then later on you can go for industrial scale mass production. Yeah, now I'm coming up to application areas. I just mentioned biomedical, but we have actually a lot of application areas that you can use the electrospinning machines that we provide. Most of our clients are coming from filtration industries, and they're coming from air and water fields. Apart from that, we have many clients in biomedical for wound dressing and drug delivery, and sometimes some of our clients require vascular graft production. So at that stage, we offer our, let's say, lab scale equipment along with a coaxial system, which will allow you to have core shell fibers as well. So right now we are coming up to another applications too, which are cosmetics and energy. So for cosmetics field, we have face masks and skin patches, acne patches, so they're all available once you purchase the equipment and run for your product development. So for the energy field, we have batteries and fuel cells. You can actually have battery separators, and you can use it for even automobile sector too. So in this R&D service field, we are actually having quite a range of R&D services, not limited to the list that you see on the screen. We are, of course, offering literature reviews. We have early trials. We have optimization, scaling up process, and then later on we have industrialization process. So we mainly start from the beginning, and then we can go up to industrialization. Actually, in this electrospinning technology, it is sometimes hard to actually overcome to this scalability, but with Innovenso and with our services and products, we can easily overcome these problems in the sector right now. So lastly, we have the contract manufacturing. As I mentioned in the beginning of the presentation, that you actually order at a certain amount of product, and we develop the material for you, and you can order it easily. And if you have the ready recipe, actually, we directly start using it and directly produce and send you the materials that you require. Depending on how much you require, of course, we develop it and we just, provide it for you. So if you have any questions regarding our products or services, I think in the coffee break, you can come up to our, stage over there. So I would be happy to answer all of your questions. If you have any more questions, you can contact us via email too. Our emailing address is sales@innovenso.com. So thank you very much for your time. So if you have any questions, I'm happy to answer them. Thank you. I think there is no question. Thanks a lot.
We have questions. We will keep you here.
Okay.
Innovenso is our gold sponsor, so please firstly accept this kuponun İngilizcesi ne hocam?
Mug.
Glass.
Mug.
Mug. And this is our certificate, it is gold color.
I think it suits my blazer.
Okay.
So, thank you.
So, as the chair of this, actually this meeting, I was going to ask, the El Marco is also producing this, nozzle systems.
Yeah.
What are the differences between yours and theirs?
Well, actually, El Marco is having another technology. Of course, it's needleless system.
Yeah.
However, in our needleless system, we have the rods and we have more production rate. Apart from that, we have definitely offering another combined machine, which El Marco doesn't have, which is an interchangeable option of our electrospinning machines. For example, you can obtain open surface machine, but you still would like to have a hybrid technology, which is, as I mentioned, needle-based, more controllable process. You can definitely change the rods. You can integrate the needle-based system, and then you can remove it and you can put the needle-free system. So we have a very huge advantage over El Marco's machines in this regard. Thank you.
For you.
Thank you. I appreciate it.
Evet, bugünkü oturumun sonuna geldik değerli katılımcılar.
Ali Hoca kapatmadan
Hocam.
önce Ali Hoca'ya kupasını takdim
Benim
edelim.
kupam.
Oturum başkanlığı yaptığı için teşekkür ediyoruz hocam.
Sertifikamı da verebilirsiniz.
Sertifikan da var mı? Oo, sertifikası var.
Yani kendi kendime verecektim. İyi oldu.
Sertifikan da verdim. Teşekkür ediyorum.
Evet, şu anda bulunduğumuz salon sağ olsun Gebze Teknik Üniversitesi'nin nanoteknoloji merkezine bir seyahat olacakmış. Yani isteyenler ziyaret edebilirler. Onun dışında çay kahve ikramı olacak yeniden.
4'te burada buluşuruz.
4'te tekrar buluşmak üzere.
4.30.
İşte.
4.30.
Biz 4 diyelim de yine 4.30 olur herkes için.
Bazı dokunuşlar yaşamın her anını etkiler. Bazen en ince ayrıntılar bile dünyayı değiştirecek bir hikaye yaratabilir. Tıpkı benimle dünyayı değiştiren Aksa'nın hikayesi gibi. Akrilik elyaf, işte benim adım. Vatanım Yalova. Güzel ninniler ve gülen yüzlerle dolu bu topraklar. İşte hayat bulduğum yer, Aksa, dünyanın en büyüğü. Hadi gelin size biraz evimi, Aksa'yı gezdireyim. Burası doğduğum yer. Dediklerine göre yüne en çok benzeyen elyaf benmişim. Ah, suyla ilk buluşmamı nasıl unutabilirim ki? İlk adımlarımı atmaya tam da burada başlamışım. Elimden tutan Ali Usta hala aklımda. Dünyam rengarenk. Farklı renklere bürünmeyi çok severim. Esneklik ve sağlamlık benim için olmazsa olmaz. Çok seyahat ederim. Arabalarım, makinalarım, bisikletlerim, hatta gemilerim bile var. Amerika'dan Asya'ya 5 kıtada 50'den fazla ülkede tanırlar beni. Nerede sorsanız gösterirler. Bazen yolda görürsünüz beni, bazen pupa yelken denizde. İlk adımlar atılırken de oradayımdır. Beraber keyif yaparken de. Bir bakmışsın arkadaşın olmuşum. Bir bakmışsın göklerde bir kuş. Hayırlı işler de benimle başlar. Göz nuru el işleri de. İnsanı nasıl seviyorsam doğayı da öyle severim. Her yeşile saygı duyarım doğanın tüm renklerine duyduğum gibi. Ben akrilik elyafım. Aksa'yla hep yanınızda. Durmadan, duraklamadan, sürekli büyüyerek, nefes alıp nefes vererek, 1968'den beri. Aksa.
Istanbul, the cultural capital of Turkey that has been home to a range of different eras for centuries, transforming the nation's home into beauty. It is the harmony of the colors and designs from a combination of these periods that gives our collections their originality, form, and spirit. This has enabled our production and service to touch the lives of people living across 6 different continents. At Kets, we harness our 100-year design and production experience to turn your lives into an elegant and comfortable experience. It all starts with an inspiration, one that comes from within life itself, from the heart of nature. What could be more important than realizing the dream of a talented designer, or witnessing your happiest moments while adding beauty and comfort to them? Each customer expectation is special, and so is each design. Thanks to our personalized and versatile design capabilities, we produce quick and effective solutions for your needs. Here in Kets, a fully integrated production facility operates as a value chain, designed for the sole purpose of maximizing customer satisfaction. A machine can only serve an idea, one that gives meaning to life. What makes us powerful is not the fact that we are the largest production facility in Europe, but that we're a strong strategic partner who can understand your expectations and help you realize your business goals. And our robust design and R&D department are the key to develop new and custom solutions to add value to your businesses. We are more extensive, more collaborative, and more responsive to your changing needs and expectations. Thanks to our excellent supply management and consistent quality, we're your reliable global partner who can offer timely solutions wherever you are in the world. In addition to our gorgeous upholstery fabric collections, we engage in other walks of life by designing and producing high-performance specialty fabrics for use in coaches, trains, airplanes, hospitals, and hotels. It is this thrilling journey that leads us to happiness together with millions of people around the world. Kets, beauty and comfort.
ایران فدای اشک و خنده تو، دل پر و تپنده تو، فدای حسرت و امیدت، رهایی رمنده تو، رهایی رمنده تو. ایران اگر دل تو را شکستند، تو را به بند کینه بستند، چه عاشقان بینش
Bazı dokunuşlar yaşamın her anını etkiler. Bazen en ince ayrıntılar bile dünyayı değiştirecek bir hikaye yaratabilir. Tıpkı benimle dünyayı değiştiren Aksa'nın hikayesi gibi. Akrilik elyaf, işte benim adım. Vatanım Yalova. Güzel ninniler ve gülen yüzlerle dolu bu topraklar. İşte hayat bulduğum yer, Aksa, dünyanın en büyüğü. Hadi gelin size biraz evimi, Aksa'yı gezdireyim. Burası doğduğum yer. Dediklerine göre yüne en çok benzeyen elyaf benmişim. Ah, suyla ilk buluşmamı nasıl unutabilirim ki? İlk adımlarımı atmaya tam da burada başlamışım. Elimden tutan Ali Usta hala aklımda. Dünyam rengarenk. Farklı renklere bürünmeyi çok severim. Esneklik ve sağlamlık benim için olmazsa olmaz. Çok seyahat ederim. Arabalarım, makinalarım, bisikletlerim, hatta gemilerim bile var. Amerika'dan Asya'ya 5 kıtada 50'den fazla ülkede tanırlar beni. Nerede sorsanız gösterirler. Bazen yolda görürsünüz beni, bazen pupa yelken denizde. İlk adımlar atılırken de oradayımdır. Beraber keyif yaparken de. Bir bakmışsın arkadaşın olmuşum. Bir bakmışsın göklerde bir kuş. Hayırlı işler de benimle başlar. Göz nuru el işleri de. İnsanı nasıl seviyorsam doğayı da öyle severim. Her yeşile saygı duyarım doğanın tüm renklerine duyduğum gibi. Ben akrilik elyafım. Aksa'yla hep yanınızda. Durmadan, duraklamadan, sürekli büyüyerek, nefes alıp nefes vererek, 1968'den beri. Aksa.
Istanbul, the cultural capital of Turkey that has been home to a range of different eras for centuries, transforming the nation's home into beauty. It is the harmony of the colors and designs from a combination of these periods that gives our collections their originality, form, and spirit. This has enabled our production and